Okay, so let's go ahead and take a look at Chapter 4, Practice Questions. Question number 1 says that consider the diagram to the right. I realize it's below, but I'm sure you can figure that one out. At point C, and the original one didn't have a point C, it just had the point. And I realized later that I had covered up the C to try to do a different problem, but point C is still going to be this tangent point. We talked about that in class. You should assume that that's the case anyway with that tangent point between the budget line and the preference that we have there. So with that, we got to take a look at these following statements and see which one is true. This here is an issue. I'm not sure why that popped up that way, but it's some coding that came through on the question. Once you work on the problem, you realize that it's irrelevant. So if something like this was to happen, if this says all of the above, that means every single one of these would have to be true. Not knowing what this is, now you can only assume that these two have to be true. And when we take a look at this second option, it does not come out to be correct. So let's just take a look at the problem. And knowing our budget line, we know that we have a certain amount of money. The big thing is that we have to look at what is the slope of this figure. So we have 12 on one side and 16 on the other. So let's just make that as a ratio, 12 to 16. A 12 to 16 ratio can be reduced down to a 6 to 8 ratio, which is then reduced down to a 3 to 4 ratio. And we do the division from a ratio to a fraction. We can see that's 3/4. Now, why is it negative? Why is it a negative 3/4? It's a negative slope, negative proportion between those two. So that's your negative slope. Number 2, American Medical Association reported that the consumption of green peas would lower the likelihood of breast cancer. I wouldn't be jumping in too soon on that one because I hate the taste of green peas. Which of the following diagrams best illustrates the impact of medical announcement? So when announcements like this come and go, but when they do come in, obviously people are going to say, hey, that's a great idea. I need to go buy green peas. And as a result, supply and demand, demand goes up, supply goes down, prices adjust. And when we look at all of these different options up here, what would result in somebody wanting to purchase the same amount at a higher price, or to come into the market at a high price compared to what it was before this announcement was made? And the result of that is because of the shift in demand to the right. These over here are asking, well, do you know that it's a shift in quantity demanded, meaning that the demand line stays the same, you just move up and down. So at a higher price, you want less of it. At a lower price, you'd want more of it. In this case, at a higher price, you'd want less of it. At a lower price, you'd want more of it. But that along the same demand line. That's not what happened. In this case, there's all of a sudden a new market that opens up. There's an increase in demand, and that shifts to the right. So our answer for this would be A, and that's a shift in demand to the right. Really like these questions. They make you think quite a bit. We were talking about consumer surplus, and we know that consumer surplus is that amount above the price that they have to pay within their budget. So, example, at $8, the surplus, and I would buy 20 of them, but the surplus would be this little triangle up here. At $5, I would buy 50 of them, and the surplus is this area above here. Now remember, when we're trying to find this out, we have to find out the area of this entire square first, and because we're talking about a right triangle, we're going to just divide that by 2. So our first thing is that we have a price of $5, because it says $5 per pound. At $5, I'm willing to buy 50 of them. So 5 times 50 is 250. We're going to divide that by 2 because we need to get rid of this other half, and that's going to come up with 125. So our answer for this is 125. We're going to use that same information a little bit differently this time. Now we're going to take a look at the market price increase. So it's an increase from, it was here, so there was a $5 difference before. Now the price goes up to $8 a pound. So which of the following statements is true? Now we're going to be calculating based on $8 per pound. So when we go in with the whole amount, we know that before we had the 250 divided by 2, that was the 125. When we calculate it at 8, we know now that the delta for price is 2 between 10 and 8. So delta for price is 2. And the quantity that we're going to get for that is 20. So here's our Q, which is 20. So 2 times 20 is 40. And that gives us the 40 right in here. We have to divide it by 2 so that we only get this right triangle. And 40 divided by 2 is going to be 20. So how are we going to figure out the situation where we're at? We're going to just take the 125 that we originally had. We're going to subtract 20 from that, and that's going to give us $105. So we're better off by $105 as we look at these market price changes. So here's what the second price change resulted in. The first price change was between 5 and 10. So here's your math over there. Double check on these. Don't quit. Don't just do one or don't just do the other, because you could come up with this 20 and you might have chosen this. And that's not where the problem is. You have to then go back and say that was our original value. We're going to subtract out this other top value to see what that savings was. Number 6, pretty straightforward. The graph depicts a perfectly elastic demand curve. Remember, if we have demand, imagine that there's a weight hanging on that demand curve, and if it's totally flat all the way across it and we hang that weight on it, we're going to see that elastic bend or stretch, and that's kind of representative of it there. So a flat demand curve means it's perfectly elastic, which means we will pay this price for whatever quantity we get. We have a specific price that we're going to pay. In 6, we have buffalo wings and soda. So as we read through the question, again, sometimes these things are really good if you just go to the very last part that's asking you what you need to know before you read the whole question. What is the maximum number of buffalo wings that Robin might buy? Well, if we say that Robin has a budget for $12 a week. Excuse me, I have a wrong budget in there. Get this back to 12. So she has a budget for $12 per week. So at $12 per week, how many wings is she going to be able to buy? Do we care about the sodas at all? If she only is worried about buying wings, we don't need to worry about the cost of the sodas. So we have $12. When we look at this, we realize that wings are 50 cents a piece, which means that we get 2 of those for each dollar that we have. So we're just going to take that $12 and we're going to multiply it, divide it out, by those 2 that we get per dollar, and we end up with 24. So 50 cents a piece, 2 of them get you $1. We have $12. 2 times 12 is going to be your 24. Number 7, suppose that Robin gets $12 a week for wings and suds. Price of buffalo wings is 50 cents while the price of Coca-Cola is $1.50. We're really doing the same thing. We're just now doing it with soda at $1.50. Over here, I just kind of put a schedule together. So if we buy 1, it's $1.50. 2 is 3, 4.50, and so on all the way down. So how many do we get? 1, 2, 3, 4, 5, 6, 7, 8. So our answer is 8. Ceteris paribus is just going to mean that we leave everything else the same. We're only looking at a single factor, so we're holding all other factors constant. We know that early on in economics, we keep it this way because it helps us discover those things that we're just trying to isolate. Later on, we know that there's multiple factors that are involved in a lot of decisions and a lot of things that occur, so then we have to use a little bit different mindset. But at first, ceteris paribus is the Latin phrase for everything else the same. So when we think about the consumer's income and the amount of food money they spend on food each year, Engel's law says that it is the proportion of income spent on food is going to fall. When we say it falls, example here, if I have $10,000 a year and I spend $1,500 on food, then 15% of my income is on food. So if I was to make $20,000 a year, and I still $20,000 a year, I might choose to have a little bit better food, or pay a little bit more on food. Let's say I spent $2,000 a year on food. Well, that is an increase over this $1,500, but it's actually less of a percentage of my annual income that I spend on food. So imagine if you spent $100,000 a year, you wouldn't be spending 15% of your income on food. So as we make more and more, a smaller proportion or a smaller percentage of our income is spent on food. Question 10. Again, if we look at the last part right here, it says, what is the quantity demanded of ice cream at the price of $1.60, assuming that only customers in the market are the customers A, B, and C. So all it's asking is go ahead and find what's the price per quart that they're willing to pay. And at that price, this person wants 5, this person wants 12, that person wants 8. We're just going to add those together, and that gives us the market demand, the quantity demanded by that market. So it's a pretty simple question. Don't get caught up too far in that.